And then last but not least, and there's an easy way to remember this that I'm going to tell you guys in a second here. But I want to show you tan first before we get into that. So let's talk now about tangent. So the tan ratio, the tan of theta, okay, the ratio is going to be the opposite side. So from that angle over there, OPP, divided by the opposite side, divided by the adjacent side, the side adjacent to the angle. So tan is opposite over adjacent. So again, in our example, if this is 3 and this is 4 and this is 5, the tan of that angle there, the tan of theta, would be, the ratio of it would be the opposite side, which is 4, divided by the adjacent side, which is 3. So the ratio, if a question asks you, what is the tan ratio, not ration, whoops. What is the tan ratio in this triangle of this angle right here? Well, it would be 4 divided by 3. Okay, that would be the tan ratio. So there's a really easy acronym for you guys to remember. I'm going to kind of get rid of all this. And of course, you can pause this and go back at any time to review what I've said about these things. But there's a really easy acronym to put into your brain that you may have heard before in, like, your casual math conversation that you have with your friends. No, I need my eraser to work. Sorry, just bear with me here. I'm going to erase those things. Okay, it can still be a 3, 4, 5 triangle. Does it bug you as much as it bugs me that these lines are not connected anymore? It really bugs me, but that's not going to look great, but that's okay. So the way to remember the trig ratio, sine, cos, and tan, there's a acronym, and it is SOH CA TOA. SOH CA TOA. Might sound like gibberish right now, but trust me, it's easy to remember if you just repeat it in your brain a lot. SOH CA TOA. If we were in class, I would say it to you 1,000 times. SOH CA TOA. SOH CA TOA. And what SOH CA TOA is it represents, this is the sine ratio, this is the cosine ratio, and this is the tangent ratio. So the sine of my angle, let's call this angle theta right here, it's this angle we're measuring, will be, the O stands for the opposite side length, divided by the H stands for the hypotenuse. So the sine of theta in this case would be the opposite over the hypotenuse. So 4 over 5. The CA in this acronym is the cosine of theta. The cosine of theta, of course. That's still my angle. The cosine of theta is, of course, now the A in CA stands for the adjacent side, which, remember, I'm looking at my angle, it's the side beside the angle, divided by the H in CA is hypotenuse. So the adjacent side is 3. The hypotenuse in this case is 5. Does the hypotenuse change position ever? No, it's always the longest side. It's always across from the right angle, okay? And finally, the tangent of theta. So that's the TOA part, the tangent. Well, you might be able to guess what the O and the A are. The tangent is the opposite divided by the adjacent. So the opposite, which in this case, because the angle's over here, the opposite is 4, and the adjacent is 3. So opposite over adjacent, that equals 4 over 3. That's the tan ratio, all right? Now, here's a thing that throws people off. If we have a triangle that looks like this, and I suddenly want to look for a different angle, I don't want to look for this angle right here, but I want to look for this angle right here. Let's call it theta. And we can do that because it's just a variable. Theta is just a variable. So now I'm looking for this angle. Well, the sine of theta turns into, instead of 4/5 opposite over hypotenuse, it's still the opposite side divided by the hypotenuse, but the opposite side becomes 3 in this case. And the hypotenuse is 5. So the new ratio is 3/5. I hope that makes sense to you because I have a new angle. My ratio is different. This is now the opposite to that angle. The cosine of theta, well, that becomes the adjacent side to the angle over the hypotenuse. Sorry, my writing is getting super messy over there. That's hypotenuse. And the adjacent side to the angle is the side beside the angle. So this is now the adjacent side, and the hypotenuse stays the same. So the cos ratio of that angle becomes 4/5, which is different than this one. You see, it's different. It's not the same. It's because the angle changed. And then the tangent of theta. Ask yourself, does the tangent of theta change? Of course it does, because I'm going to do the opposite over the adjacent. Opposite over adjacent. And the opposite side to that angle changed. The opposite side is now 3 over the adjacent side, which is 4. Okay, so you see how these are different now. Guys, I hope that makes sense. That's the basics of trig ratios and SOHCAHTOA. The next video is going to have examples that we're going to find side lengths of.